Hi everyone, my name is Abdullah. In this video I'll be demonstrating several XSS vulnerabilities using PortSwigger Academy and Burp Suite. Task 1, which involved creating my PortSwigger account and installing Burp Suite Community Edition, was completed off screen. From here I'll jump straight into the hands-on labs and walk through each task, explaining what the vulnerability is, how the payload works, and how I confirmed the exploitation. So let's start with task 2. Starting with task 2, this lab demonstrates a simple reflected XSS vulnerability where user input is placed directly into the HTML response without any encoding. Here I'm using Burp Suite's embedded browser, and I start by enabling interception in the proxy tab. I enter a random string into the search bar, hit search, and Burp catches the request. When I look at it in the proxy, I can see the search terms being passed through the URL as a parameter. This is a classic GET request, which normally has no body. All parameters are included directly in the query string. Next, I send this request to repeaters so I can modify it manually. In the inspector, I can see the search parameter holding my input. I replaced the value with a basic XSS payload, script alert1 script. After clicking send, I check the response. The server returns a 200 OK, which means it didn't block or sanitize my input because the input is reflected straight into the HTML. My script executes and the alert box appears. This confirms the vulnerability and completes task 2. In my case, it only told me that the lab has been solved. Moving on to task 3. This one is more advanced because the lab introduces a web application firewall that blocks most common tags and attributes. The goal here is to bypass the filter and still achieve XSS execution. I start the same way, intercepting the search request. I try a typical payload like image source equal 1, one error equal alert, document.cookie, but the lab responds with tag is not allowed, which confirms the WAF is doing partial filtering. To bypass it, I go into the HTTP history, send the request to intruder, and configure a sniper attack. Intruder lets me send the same request repeatedly while testing different payloads. I clear the URL parameters and set the insertion point. Then I open the PortSwigger XSS cheat sheet. Copy the full list of tags and paste them into payload configuration. These vectors are specifically designed to help bypass filters and WAFs. I start the attack, and when it finishes, I analyze the responses. Most payloads return a 400 status, but a few, including the body tag, return 200 OK. That tells me the filter did not block them. Next, I repeat the process using event handlers from the cheat sheet. After pasting the event list and running a second intruder attack, I notice that onResize event generates a 200 OK. This is my working payload. Now that I have a valid bypass vector, I use the exploit server provided by PortSwigger. I then craft an iframe pointing back to the vulnerable lab with the working event payload embedded in the search parameter. I also include an onload attribute to force the iframe to resize, triggering the onResize event automatically. After storing the exploit, I view it and confirm that the alert pops up. Then I send it to the simulated victim, and the lab marks as solved. Task 3 shows how attackers can automate payload testing and use event-based vectors to bypass restrictive filters. Now moving into task 4, we shift from server-side reflection to a DOM-based XSS vulnerability. Here the JavaScript code on the page takes input from location.search and writes it directly to the DOM using document.write. I open the inspector and type a test search term like ABCD in the Elements tab. I can see that this value is inserted into an image tag through document.write because there's no sanitization. I can break out of the existing HTML structure. To exploit it, I modify the URL and insert a payload that closes the existing context and injects my own code. A simple example is SVG onload alert 1. When the page loads, the SVG onload event fires and triggers the alert that confirms the DOM-based XSS is in this lab. Finally, in task 5, the DOM-based XSS gets more interesting because the vulnerable input is placed inside a select element. The page uses document.write to build the drop-down options based on the store ID parameter taken from the URL. First, I inspect the stock checker form and confirm that the store value is being inserted directly using document.write option selected plus store plus option. Since the value comes straight from location.search, an attacker can manipulate it by editing the URL. I test this by changing store ID equal ABCDE, and I can immediately see the drop-down update to reflect my input. To exploit this, I need to break out of the select tag. I encode my payload, image source equal 1 error equal alert 1 into URL format, then prepend it with select. So it looks like select image %20 source equals 1 %20 1 error equal alert 1. I insert this into the URL as a store ID parameter, reload the page, and the injected image tag executes its on error handler, firing the alert box. This confirms that even content inside a select element can be exploited if the application blindly uses document.write with untrusted input. Task 5 is successfully complete.